In other planetary systems, we see evidence that giant planets like Jupiter can migrate from where they originally formed, spiraling inward to an orbit closer to their stars. When these giants wander toward their stars, any small, rocky planets that stand in the way can be swallowed up or, due to the giant's strong gravity, flung out of the star system altogether. But if Jupiter-like planets remain distant from their stars, they can serve as the gatekeepers to their planetary systems. In our solar system, Jupiter can eat up any asteroid or comet that ventures near, earning the nickname, vacuum cleaner of the solar system. The asteroid belt in between the orbits of Mars and Jupiter is another example of the gas giant's influence. Its gravity likely prevented the asteroids from combining into a planet. Jupiter can also radically alter the orbits of small bodies that stray close, hurling them on long orbits that take hundreds or even thousands of years for those bodies to return. We think this is how comets got the extreme orbits that carry them to the far-flung reaches of the solar system. They spend most of their time out there, forming a cometary collection called the Oort cloud, which may extend as far as halfway to the nearest star. While Jupiter often protects Earth and the other inner planets by deflecting comets and asteroids, sometimes it sends objects on a collision course straight toward the inner planets. Earlier in the solar system's history, when there were more objects flying around, the increased amount of impacts would have brought to Earth water and other ingredients for life. Of course, other collisions would have been disastrous, such as the impact that likely led to the extinction of the dinosaurs 65 million years ago, would have been disastrous, such as the impact that likely led to the extinction of the dinosaurs 65 million years ago. Many Jupiter-sized planets in other solar systems orbit their parent stars in small orbits, similar to the orbit of Mercury, the planet closest to the Sun. These orbits mean that most of them would have to cross the orbits of Earth-like planets to hurl them into space, making life impossible. But Jupiter moves in a perfect circular orbit, preventing collisions with these planets and enabling life. Since the 1980s, astronomers have assumed that planets the size of Jupiter originate in space around their host star. We now believe that giant planets like Jupiter were the cornerstone of planet formation. They were assembled during planet formation, when they were too young to have the chance to absorb the bursts of light and gas from the giant clouds from. Astronomer says only a fraction of the rock was sent on the right trajectory and speed to join the asteroid belt. The movement of the planets in the early stages of instability was the result of the gravity of Saturn and Jupiter, which absorbed material and headed other asteroids toward other planets in our solar system. Simulations suggest that about 3 million years ago, gravitational interactions between Jupiter and Saturn's protoplanetary gas disk drove Earth-sized planets around the Sun into elliptical orbits.